which is also a high availability cluster configuration for Oracle. It requires actually 4 different networks, and one of these networks is a private network, which is used for nothing else but for heartbeat between those 2 nodes or multiple nodes in the cluster, and for cache buffer exchange. So this is why it is so difficult, because if we are forcing enterprise level applications onto cloud, and their philosophies are different. For cloud, you want to be flexible, you do not want to really, you just want to kind of optimize the usage and completely disconnect from the hardware. And for clusters, you have to have fine-grained control of the cluster. So let's have a look into actually the hardware. How can we do that? Right, so this is a power server building block, which is one rack, top of the rack. So on the top of the rack, there are those top of the rack switches, because there are, each of those, it is hosting 4 nodes, P770 servers per rack. There are 2 here and 2 here, and top of the rack there are switches. Each of those nodes has 64 core blocks and terabytes of memory, and can serve number of VMs. So if we want to add this additional network, that 4th private network that I was talking about, for just heartbeat, then what we can do is we can use this top of the rack switch and interconnect. This is the same, right? This is one, is here, right? So we can connect those double rack with a redundant network and make that traffic stay within network traffic, stay within the twin rack. So it does not read the switch, it does not interact with other network traffic within the data center, because somebody else may be doing backup and so on. So you do not want to leave the twin rack. And in actually power systems, it turns out that it is a non-disruptive process to add this 4th network on top of existing networks to run the cabinets. And because the network interface cards are hot pluggable, so we could add cables just connected into the empty slots, which we have sufficient number of empty slots to configure them and to actually enable full network for rack. Obviously, now if we have our nodes, some of those should be sitting here and some of them should be sitting here. So your node has to be on 2 different systems to achieve anti-collocation, because you do not want all of your customers sitting on the same server, because if that server goes down, you lost everything. You want to kind of spread them around, that if you lose one system, that there are still some surviving nodes around. So that is what we have done for CMS to enable Oracle RAC, which required 4th network. And we can go even higher level, and those application level, high level. Basically now we are talking about new breed of applications, born in the cloud applications, which are actually more and more emerging, which is new world, which are Netflix and Facebook's type applications, which are stateless. So losing any of these does not matter, losing any of the applications, because no state is associated with that. Of course, you cannot, not all applications are stateless. So what is happening is you are taking your application and trying to pull out of it parts which can be stateless as a microservices. So you pull as much as you can out of it and say this is stateless, and then the small amount which has state is then implemented as a stateful application, which reliability, which requires failover to maintain servers, and you cannot completely avoid it, but it can be minimized. So majority of your application can be done to be stateless, and then for you use high availability for those small parts which have to be with state, keep state. And as the last part of this talk today, again, that was at the application level, resiliency at the application level. But there's also disaster recovery. So the question is, as a business, how much can you tolerate disaster? What if something happens? And we have seen last year there are so many disasters happening. with earthquakes, with tsunamis, with hurricanes, their data centers are going down and are not available. So what if something happens and the whole data center site is gone, right? So how long can a business tolerate to be offline, and how much data you can lose? So if you are a bank or insurance, not operating for a few days can cost you millions and millions of dollars. So not every business cares about disaster recovery, but there are enterprises for which loss of operation is not tolerable. So for that, they need better plan than just trying that it's not working. So they have to have a plan in place. The two basic matrices for around disaster recovery are RTO and RTO. RTO is recovery time objective. That means how long will you need to recover. So how long does it take for you to set up your business again, to run again? And there are RPO is recovery point objective, and that is what is the point that you are recovering to before disaster? Is it 24 hours before you say 24 hours before the disaster, or it's 5 minutes before disaster, or it's 0 minutes before disaster? To what point will you recover? So let's have a look at the traditional disaster recovery approach. Most common approach, again, is failover, where there is a recovery site, which can be either dedicated or shared, and the data from the data center are backed up, and they can be either electronically or with tapes. So electronically data are backed up, and with the disaster recovery sites, then you have to get your data into the recovery data site, so that is when failover is happening, and you continue running from here. If you are using data backup with tapes, then those tapes are basically have to find their way from the vault. So typically they are kind of backup is done on tapes. Somebody comes and takes those tapes and brings them in vault, and then those tapes are in vault. So in the case of disaster, somebody goes to vault, get all those tapes, bring them to the failover site, and install the data back from the tapes. So obviously, this is a lengthy process, right? It takes weeks to do that. So that is the traditional. Another, if you are a bank or business who cannot tolerate that long to be out of business, you can have your hot site. You can have another data center just like your own, sitting somewhere and being ready. So it can be even on hot standby, and you will constantly ship your data from your data center into the backup data center. And if disaster strikes and you lose your data center, well, the other data center is already set up, data is already there. You can just switch there and run. Well, obviously, this costs a lot of money to have another data center just sitting there and waiting for disaster to happen so that you can run there. Obviously, not everybody can afford that. And then there's active organization, where you can have, again, similarly, you can have multiple data centers, and your operation can run, your application can run on all of these data centers, and you are actually load balancing. You are spreading your workload on one or the other, and if you lose one data center, obviously, similar like for the clusters, active, if you lose one, then the other one is still continuing to operate and is working fine.